All right, let's go over these review problems. I'm going to do this in small pieces so that I can go over them in depth, and then you can just go to the problem you have a question on that you did not understand on the review key that you looked at that was stated. All right, so this video is going to be numbers 1 through 6. So here we had this problem where we were asked to interpret confidence level. And so, a key here with interpreting that confidence level is you know that you're actually not going to be saying anything about the specific interval. So, whereas we were told the specific interval that you got was from 0.38 to 0.42, then I do not reference that single interval when I'm talking about confidence level. So, right there, 3 out of those 4 answer choices are out. Then the next thing I go to look for is to make sure that it's talking about the times, the amount of time. So 90%, or in this case, 98% of all 98% confidence intervals will contain the true parameter, the population mean or population standard deviation. And so C talks about containing the true proportion of readers who read either in print, but this one talks about 98% chance of containing a randomly selected reader. And that's not what an interval is about. Containing one single one? No, it's about containing the true proportion. Okay, number 2, we talk about going from 98% confident to 95% confident. Okay, so what's happening? Well, we can see here that, of course, a wider interval is a 98% confidence is wider interval because you are more confident that you are capturing that true proportion or true value. Also, I've referenced down here that you can see, the critical value, the Z star for 98%, of course, is bigger than 95%. So my students today asked, why is that making it less precise? So they wanted to say that it was more precise because you were more likely to capture the true answer. No, being wider is a broader range. You're going to tell me that the weather's going to be from, 4 degrees to 104 degrees. Well, you may be 98% confident of that, but that is not very precise. So the wider you get, you are actually less precise. Okay? So more precise would be narrowing in and pinpointing a value. All right, so with number 3, the key here is that it's asking about this definition of p-value. I very specifically laid out those 3 things that you need to include for the definition of p-value. You need to talk about that the p-value is a probability of getting that particular sample results, specific sample results, or more extreme, if the null is true. And you want to say that null hypothesis in context. So it all in context. So it contains these 3 things. If the null is true, there's a this % probability of getting that sample results we got. So I laid that out here, and you can see I color-coded it even. C says if the mean cholesterol for the placebo and the medication were really equal, so that because that is the null hypothesis, we start off saying they are equal, then there's only a 1% chance that we would have gotten the difference such as that or something bigger, a difference that big or greater. Okay? All right, number 4. Now, number 4 was really tricky for me. I actually had answered it wrong the first time, and I kind of had to go through and reevaluate it and kind of see which one is the lesser of the worst answers. And even the answer choice I chose was not my favorite. I'll tell you what I would have liked better than what they put for A. So this was an interpretation of an interval. Okay, so I am going to be referencing this specific interval. Okay, and this is about the average number of miles driven. So let's actually go through the wrong answers and why they're wrong. Okay, so B says, and it is a 90% confidence interval. B says 90% of all female drivers drive between this much. So what this problem has done, it's turned into the proportion of female drivers, and it's not talking about the average number of miles driven. It's not talking about the average number of miles driven. It's talking about the proportion of female drivers who drive in that range. So that has really kind of changed the units. It's not about the average number of miles driven. So that's what's wrong with B. C says, we are 90% confident that a female. Oh, I liked this one at first. In fact, this one is the one I had chosen first. But then in hindsight, after I reread it, I thought, whoa, this is talking about one individual female falling in my interval. No, intervals are not about one single event or even a sample of somebody else's sample falling in my interval. It's about, did the true population average fall in my interval? So that's why C is out. D is a wonderful, perfect, beautiful answer for confidence level. Okay, it talks about, 45 of the 50, so that's 90% of the confidence intervals on average would contain the true driving mean. Okay, so that's what confidence level is saying. How many of those 90% confidence intervals are going to contain the true mean miles driven, so on. Now, E is wrong for a couple of reasons, actually, has several things. So first, we're kind of talking about in repeated samplings. This is like the confidence level kind of idea, multiple intervals, okay? Then the average miles, number of miles driven by females age 16 to 19. I like that, okay? The thing I don't like about it's almost like saying if we took many samples, then the samples about, the samples would fall into this interval. So here was the X bar, or the margin of error. They would be within that margin of error of this. So they would fall within that interval 90% of the time. So whether it's talking about other samples falling in the interval, or it almost sounds like it's also trying to talk about how the true mean is in the interval 90% of the time. Well, that sounds to me like if it's not in the interval 90% of the time, then the true mean is somewhere else 10% of the time. That means the true mean is moving. Sometimes it's in there, sometimes it's not, and the population mean cannot move. Therefore, by default, although A is not my favorite answer, we're going with A. It says there's a 90% probability that the true mean is between 6460 and 7100. I don't love that answer, but it is talking about the true mean, and it's talking about it falling, it being in this interval. What would have sold me on this, if it's not talking about the probability of this being in the interval, of the mean being in the interval, if it had said there's a 90% chance or a 90% probability that this interval contains the true mean, then I would be sold. And that would be, I would feel 100% comfortable with that. Okay, 100% confident with that. All right, so tricky one, lots of little details there, but that's what it boils down to. Okay. Next, number 5. So keep in mind that on this one, we were not told the population P, nor were we told a population P hat. So if you are not told either one of those, then your last resort is to use 0.5 as your proportion in there. Okay, and then you need to know this here, that when you are making an interval, there's your p hat, okay, and then this margin of error comes from that z star, this z star here times that standard deviation. Okay, this is how you get that whisker, which is that margin of error. All right, so then we go and solve that. They told me to have a 7% margin of error. They told me to be 94% confident, which 94% confidence is in the middle. That puts me having inverse norm of one tail. So that is 1.88. And then again, here is my 0.5 times 0.5 over n. So there is the equation I have to solve for n. I guess I could go into depth algebraically with that. I don't really want to. So just make sure that you divide over the 1.8, then you square both sides, and then you will take 0.25 and divide it by the result that was over there on the left. And you get 180.33, which you always have to go up. And that's the smallest amount that you have to have. So if you had come up with 185 in this answer, you'd have to go all the way to 361 as your next answer choice, because 181 has to be at least this amount. So this much or more. Okay, number 6. So here, let's talk about statement 1. I think that one's the one that we're most wondering about. If there is sufficient evidence to reject a null hypothesis at the 10% level. So rejecting at the 10% level means that you fall in this top red rejection region, the 10%. Then does that mean there is sufficient evidence to reject at the top 5%? And that's not necessarily, because if my p-value, say my p-value was 0.075, my p-value, not okay, then that's right there in the middle. I would reject it at 0.10, but not at 0.05. Just because you're in the top 10% of your class doesn't mean you're in the top 5% of your class. All right, and statement 2, you don't decide one or two tails after you've gathered the data. You are deciding one tail upper or lower or two tails based on what the question is pondering. What are you investigating? Has this increased? Has it decreased? Has it changed? What you are investigating is what determines the tails that you use. And then the last one, if a hypothesis test is conducted at the 1% level, then there's a 1% chance of rejecting the null. No, that just, no, it depends on where your data is, Anyway, so that is not what that alpha means. Okay, so that's all for this first video, because I didn't want to get too much into them. That was just questions 1 through 6.